Rational coefficient, leading coefficient of 1, so it's something to check in the end there. 0's at 3, and 1 plus I root 5. Alright, so leading coefficient of 1, something we should see at the very, very end, but also in the beginning. It means we don't have an extra whole number in the front multiplying. There's no additional leading coefficient as a factor that we're multiplying in. So, alright, 0 is at 3 and 1 plus I root 5. What is your first step? List your zeros. Okay, go ahead and do that. So you should get 3, 1 plus I root 5. And what does our conjugates theorem tell us that we also have? You should have 1 minus I root 5. Right, we have 3 zeros. What do those become? Change those into factors. Alright, so let's write out those 3 factors. If I have a 0 at 3, I have a factor of x minus 3. I have a factor of x minus. Make sure you always start your factors with x minus and then your 0 term. So 1 plus I root 5. And then x minus 1 minus I root 5. What should I do with both of those? Simplify those down. So I have distributing that negative x minus 1 minus I root 5. Distribute that negative, you should get x minus 1 plus I root 5. So you should still see that conjugates theorem happening on those. So what's the point of taking zeros and turning them into factors? It allows you to write factored form. Right, so write out your factored form and then look back, check mine, make sure yours looks like mine. Okay, so you should have x minus 3 times x minus 1 minus I root 5 times x minus 1 plus I root 5. When we distribute these, to begin simplifying it down into standard form, which 2 should you distribute with first? You should distribute your 2 imaginary, and we actually now have imaginary and irrationals, so even more of a reason to utilize them first. It will simplify them down, rationalize them, and eliminate all of the imaginary terms first. Alright, so begin distributing those 2. I will also, and then we'll check back and hopefully you get the same terms that I do. Alright, this last one's tricky, so be careful of this last one. You might want to do it over here on the side. Okay, so hopefully you got x squared minus 1x minus x I root 5 minus 1x plus 1 minus I root 5 minus x I root 5 plus I root 5. And if you take negative I root 5 times positive I root 5, I did it right over here on the side, you should take that I squared, turn it into a negative 1. You should take that square root of 5 squared, turn it into a 5. Negative times negative 1 is positive 1 times 5 is 5. So a little side step that you have to do. All right, so following the same conjugates pattern, what should happen? You should have positive and negatives. Ooh, I did something silly there. Let's see. Negative xi. Oh, this is a positive xi over here. All right. Should have a positive and a negative of each, even if you don't. Know that you always should, and they should all eliminate. So all of your imaginaries and irrationals should simplify out. Okay, so you should have x minus 3, and you should be left with x squared minus 2x plus 6. So it should get really long, then get really short. Are you done? Unfortunately not. Right, continue to distribute. Alright, so hopefully you got x cubed minus 2x squared plus 6x minus 3x squared plus 6x minus 18. Yeah. Alright. Simplify that down. We only have one set of parentheses left, so we should have it in standard form once it's all simplified. Highest term, x cubed, of our squares. So minus 5x squared, your x's plus 12x, and your constant minus 18. Check back at the top. Did you use all of your zeros? Yes. Is it a polynomial? Yes. Least degree, so standard form. Rational coefficient. Is there a leading coefficient of 1? So if you distribute it correctly, there should only be one x cubed in the front. All right, so the next lesson that we're going to go through, we're going to combine all of these together. So we're going to use the complex conjugates, the irrational conjugates, factor theorems, all that, all into one. So watch this again if you didn't understand it so that you're ready for the next one.